Okay, review for test 1, unit 0, page 2. Let's multiply some fractions. All right, there's a couple ways you can go with this. Some people, the basic idea is to multiply across the numerators. I know my answer is going to be negative. This is a negative fraction times a positive fraction. It's going to yield a negative fraction. And 15 times 21 is 315. And 14 times 150 is 2100. Now, that requires a whole bunch of reducing. I know they end in a 5. So, let's see. Negative 63 over 420. 63 is divisible by 7. Let's try the 420. Is that divisible by 7? Yes, that's a 60. And I know both of these are divisible by 3. So, boy, that takes a lot to get all the way there. The other thing I like to do is reduce them as they stand there. So you can picture this as these going straight across this way. This is like 15 times 21 and 14 times 150. These are all, the numerator is all considered, quote, on the same side. So you can reduce, you can't reduce the 15 with the 14, but you can certainly take the 15 out of 150. There's 115 and 150, so that's 10. 10 times 15 is 150. So I can take the 15 out that way, right? Over here, there's a 3 and a 5. That's 15. So you can take a 15 out this way. And I know that a 7 goes into a 14 2 times, and a 7 goes into a 21 3 times. So then I just have to go, let's see, that's going to be a negative because one's a negative, one's a positive. And in the numerator, there's a 3, and the denominator, there's a 2 and a 10, so that's a 20. I prefer crossing things out, but if that's too confusing, you can always multiply all the way across the top, all the way across the bottom, and then reduce, okay? Which is required, right? It's not optional. All right. So let's see, the next one, I have a division and a multiplication. Orders of operations says to multiply or divide as you come to them left to right. So that means I need to do the division first. So this number divided by this number is the same. What's the expression for division? Keep, change, flip is the one I remember. Sometimes people remember one a little different than that, but keep the first fraction, okay? Change the division sign to a multiplication, and if you flip the second fraction, it's the same thing as dividing, okay? Now you can find out what the answer is to that, or you can just now multiply all of these straight across. And if you do that, you'll get negative 378 over 420. They're both divisible by 2 because they end in an even number. And then what is the divisibility rule for 3? You add up the digits. 1 plus 8 is 9, plus another 9 is 18. 18 is divisible by 3. Therefore, this number is divisible by 3. 2 plus 1 is 3. That's divisible by 3. So put it in the calculator, you get 63 and 70. 70 divisible by 7. 63 is divisible by 7. So negative 9 over 10. Now, let's check that by going back and doing this the other way. I have, let's see, I'm looking here. Is there anything that I can take out? Consider these all on the same side. Well, I know a 7 comes out of a 14 and I get a 2, and I can take a 7 out of the 28 and I can get a 4. That means I could have taken the entire 14 out and gotten a 2. I definitely can take the 3 out of the 15 and get a 5. And I took the 2 away, so that's a 1 now. So 1 times 9, so that equals negative 9 over 2 times 5 is 10. Okay? All right, 16, order of operations. Let's see. these are considered a type of parenthesis, right? And the rules are stay within the parenthesis within the parenthesis. So you're always doing the parenthesis inside of another parenthesis first. So I don't touch the 7. I leave this here. It doesn't really matter if you put brackets or parentheses. That's a parenthesis, that's a parenthesis, that's a parenthesis. Even absolute value is considered a type of parenthesis. So you typically don't see two soft brackets or parentheses. You typically see these. This is why these are called parentheses the most, because they're the most common type of parentheses. They all mean the same thing. So we want to do 5 minus 4 is 1. Put back the square, put back the parenthesis. Leave this here. Then we want to focus on doing this next. So we don't touch the 2, don't touch the 3, the square of 2, just in case it was another number. This is the order you do them in. Can't go wrong. 1 squared is 1. Put that back. 7 plus 2 plus 3. 1 times 3, right? And then 7, since there's no number here, we don't have to distribute anything, but if you stay with the parentheses, you're still there. But this is really just 7 plus 5, right? These parentheses are now meaningless at this point. Sorry, I'm looking this and I noticed that the number looks different. Oh, I forgot to change the number. Sorry. Typo. Let's try that again. Okay, I must have fixed the number here. This is not a... I think I tried to make it more realistic by putting a different number here. I don't like that 1. So if I put a 7 there... Yep, now it says the same thing. Sorry about that. So this is going to be still don't do this, still don't do that. Now we have a 5 minus 7 is a negative 2 squared. 7 plus 2 plus 3. Negative 2 times negative 2 is a positive 4. 7 plus 2 plus 12. 7 plus 14 is 21. Okay? Let's see. Class of 32 students, there were 12 men. What is the fraction? All right, so total goes on the bottom. Okay, that's the denominator. There are 12 men, and the 12 is the fractional part. So we always check if we make a fraction that is reducible. So certainly by 2. That's going to give us a 6. I must have not reduced it on the key, I guess is what I'm thinking. 16. Oh, I could have done more. Let's see. How about another 2? It's 3 and what, 8? Okay. So make sure you're always reducing fractions where you find them. Order the pair numbers using this. All right, so this is a less than symbol. This is a greater than or more than greater than symbol. 10 is a positive number. A positive number is always greater than a negative number, right? If you're thinking of a number line, there's a 0, and all the negative numbers are over here, and all the positive numbers over here, and this number line gets larger as it goes this way. So a negative 2 is over here, and a 10's way up here. The 10's always larger, okay? So this, let's see, absolute values. An absolute value of a negative 12 is a 12, okay? And then there's a negative out here, so this is going to be a negative 12, which means that's equal to that, okay? Just a quick review. If you have a 3, its absolute value is a 3. If you have a negative 3, its absolute value is a 3. If you have a negative 3, then this is a 3 times a negative 1, so this is going to be a negative 3. Okay, absolute values themselves are distances, so they're always a positive number. Okay, it's not the same as a parenthesis. It's not the same as one of these parentheses. If you have a negative 12 like this, that's still a negative 12. But if you have a negative 12 like this, that's a positive 12, because the straight are absolute value bars, which means they're distances. How far you go is always a positive number, okay? Even if you go backwards, you're still going a certain positive distance, okay? Alrighty. Let's move this out of the way. Alright, let's add and subtract some fractions. Let's see, these two numbers have like denominators. I can add them together now if you want. I can make that, negative 11 plus 13 is 2 over 24, which I can reduce to 1 over 12 plus 2. How do you add that to a 2? Well, the 2 is really over a 1, right? A 2 over 1 equals how many 12s? Well, that's times 12, so that's times 12, so that's 24. So 1 over 12 is the same as 24 over 12, which gives you 25 twelfths. That is one way to do it. Another way would be convert this 2 to a 24 way back here, so you'd have 11 over 24 plus 13 over 24 plus 24. No, it's not going to be 24 now. We're going to have a 24 as a denominator. So 2 over 1 equals what over 24? So this is 24, so 48. So this would be 48 over 24. So this would be 48 plus 13 minus 11 would be 50. 50 over 24, and you reduce it by 2, and you'll get the 25 over 12, okay? But any way you do it, make sure you show some work that we can follow, that your instructor can follow, that supports your answer, okay? All right, this one has a 24 and a 4 in the denominator, so that means we need to change your LCD. Your least common denominator is a 24. So let's see, 1/4 would be times 6 would make a 24, so this would be times 6. So this is going to be 11 over 24 minus 6 over 24 equals 5 over 24. Oops, 24, not reducible. All right, a 20 and a 30 needs to have a common denominator. So I look at the 30. There's a couple ways to do this. I usually look at the larger number, 30. 20 isn't a factor of 30. 30 times 2 is 60. 60 does 20. 60 is a multiple of 20. 20 is a factor of 60, so 60 can be my LCD for this. So need to be both converted into something over 60. Don't lose the signs. So 20 times 3 is 60, so 9 times 3 is 27. 30 times 2. Sorry, 30 times 2. So 17 times 2 is 34. A negative plus another negative is a bigger negative, and that does not reduce. And the last one on this page, round to the nearest hundredth. Hundredth is where this 0 is, and the 6 is above a 5, so you give it a shove. 5.41 would be rounded to the hundredths. 5 and above, give it a shove. 4 and below, let it go. Okay, Just to practice, what if they ask about the thousandth place? Thousandth place is here. So this 9 says to move this up, so 5.407 would be rounded to the thousandths place. Okay. All right, we'll do another video for the other page.